Today, we're going to continue our review of exponential functions with a different setup. This time, we're going to suppose that p of 0 is equal to 37, and p of x decreases by 12% every 4 units. So our description here is, instead of being described with a multiplier, we're describing the change with a percent change, still happening every 4 units though. What we need to be able to do is look at a description that says decreases by 12% and turn that into a multiplier. So decreases by 12% means that we're going to multiply by 0.88. We take the 12% and subtract it from 100 and write that as a decimal. So just take 100 minus the 12 is the 88, and then write that as a decimal. So think of it as we're losing 12%, but we're keeping 88%, and that's what we multiply by. Once we have a multiplier, we can write an equation. So p of x, we're going to write down where we start. So we start off at 37. And then we multiply by 0.88. And we have repeated multiplication, which we're going to use an exponent. And this is happening every 4 units. So there's an equation that fits this description. We start off at 37, and we decrease by 12%, which is multiplying by 0.88 every 4 units. So remember how the exponent works. X over 4 is going to count the multiples of 4. When x is 0, we've multiplied by 0.88 0 times. When x is 4, we've multiplied by 0.88 1 time. When x is 8, we've multiplied by 0.88 2 times. 8 divided by 4 is 2, and so on. So that's one way we can write an equation for p of x. So this is the percent change every 4 units. So this description utilizes the percent change every 4 units. But we might want to simplify things in the same way we simplify things with the slope, where we take the rise and divide by the run. So a good follow-up to this, to write our equation in just like 2 numbers, we could figure out what percent does p of x decrease every unit. So now we want to know the percent change per unit, every 1 unit. So there's no trick to it. It's just a simple trick. We're going to ignore the 37 and we're going to plug 1 in to the x. We're going to compare the value of p of x at 2 consecutive values of x. So compare the value of p of 0 to p of 1, or from p of 1 to p of 2. So the shortcut is to just take the multiplier 0.88 and raise it to the 1 over 4. So if we just take the 0.88 and raise this to the 1 over 4, this will tell us the percent change per 1 unit. And we just need a calculator to figure out the 4th root of 0.88. 0.88 to the parentheses 1 divided by 4, close parentheses, 0.968 0.85, so we'll call it 0.969. This is the multiplier for every 1 unit. So this means we're multiplying by 0.969 every 1 unit. So if we look at the 9.969 and read it as 96.9 and subtract that from 100, that'll tell us what the percent change is. So if I take this and subtract it from 100, or I'll just subtract 1 from this, we get minus 0.031. If we turn that into a percent, we get 3.1. So multiplying by 0.969 every 1 unit is the same as decreases by 3.1% every 1 unit. The only part we really need for this is the 3.1%. Now, this raising to the 1/4 is means we're just looking at two consecutive integer values of x. We're looking at the ratio of, for example, if we look at the ratio of p of 1 divided by p of 0, that would be 37 times 0.88 to the 1/4 divided by 37 times 0.88 to the 0/4. The 37s cancel out. We're not concerned with where things started. We're concerned with how things are changing. And 0.88 to the 0/4 is equal to 1. But if we look at any two consecutive values, if we look at, say, p of 10 divided by p of 9, we'll do 37 times 0.88 to the 10/4 divided by 37 times 0.88 to the 9/4. Just like before, the 37s cancel out. And when we're dividing things with the same base, we subtract the exponents. So it's 0.88 to the 10/4 minus 9/4, which is 0.88 to the 1/4. It's nice when all the rules are nice and consistent. When we divide things with the same base, we subtract the exponents. This is just like if we had, say, x to the 10th over x to the 9th. That's going to be x to the 10 minus 9, or x to the 1st. When we divide things with the same base, we subtract the exponents. All right. So now that we have an equation, 37 times 0.88 to the x/4, I'm going to use this one instead of the 0.969 to the x, because 0.88 to the x/4 uses no rounded off information. This is all just given information, no rounding error. We can't introduce rounding error. But we can do the same things that we did yesterday. We can plug stuff in and solve equations. So I might say find p of 10. Show your calculations, round your answer. So to find P of 10, we're just going to plug in 10 for the X. So P of 10, I've been highlighting the 10. So P of whatever is 37 times 0.88 to the whatever that is divided by 4. And that's just what we plug into the calculator. So the P of 10 will be 37 times 0.88 to the 10 over 4. So we grab our calculating machines and we do 37 times 0.88 to the parentheses 10 divided by 4. That'll be 26 point, let's call it 26.9 because I probably will say round to the nearest 10. When I say show your calculations, I don't need to see the steps. I just mean write down what you're going to plug into your calculator because I need to know 0.88 to the 10 over 4. That's going to require a calculator. I don't want exact values. I want approximations because they'll make more sense that way. So this is what counts as show your calculations. As usual with calculator exercises, when I say show your calculations, just show me what, write down or type what you're doing it on computers, I guess. So type what you're going to punch into your calculator. So now that we've plugged stuff into the function, we could ask to solve the other direction. So solve P of X equals 10. Show your calculations. Round your answer. So now we're going to set up an equation where we take P of X, which is 37 times 0.88 to the X over 4. And we're going to set this equal to 10. So now the 10 is the output on the other side. And we're trying to figure out what X will get us to a 10. We don't have the advantage like we had yesterday of a table of values where 10, we could see where 10 fell in between those values. So we have a few options. We could guess and check like we did yesterday. So let's suppose I said round to the nearest 10. We could just guess. We know that when we plugged in 10, we got 26. So what if we plug in 20? What if we go farther? We're still not down to 10. So this is going to be pretty far, it looks like. What if I go to 30? We're at 14. If I go to 40, we're down to 10.3. So actually, we're down pretty close. So it's between 40 and 41. So if I go 40.5 divided by 4, that's a little too high. So I'll go 40.4. I'll just bring it down until, like I'm playing on the Price is Right, until we're at less than 10. I'm going the wrong direction. It's between 40.5 and 41. So it looks like it's between 40.9 and 41.0. So it's between 40.9 and 41.0. And if it's the nearest 10th, then we just have to figure out which one is closer. 10.01 is 1/100th away. 9.98 is 2/100ths away. So we could just zero in. So guess and check, that went pretty fast. So guess and check, we found that P of 41 0.0 is 9.98, and P of 40.9 is 10.02 or 10.01. So we know X is between 40.9 and 41 and closer to 40.9 because 10.1 is closer to 10 than 9.98. So this tells us that X is between 40.9 and 41.0 and closer to the 40.9. So we'll declare that the winner. X equals 40.9. Is because we only had to go to the nearest tenth. If we wanted to go to the nearest hundredth, then I would just split the difference between 40.1 or 41.0 and 40.9. So 40.95, let's say. That's a little too low, and so we just count up. So it looks like it's between 40.99 and 40.9. I'm going the wrong direction again. So we could just, I'm distracted by something shiny. So we could just keep going and narrowing it down. So we're between 41.0 and 40.9. We could just split the difference there and go with 40.95. And then just drop it down, just keep zeroing in on the X that we're looking for. We could also use logarithms to solve. If we look at what turns an X into a 10, we look at the things that we do to the X. The first thing that happens is we divide by 4. The second thing that happens is we take 0.88 and raise it to the result. So I'm going to write it in this order, 0.88 to the. And the third thing that happens is that we multiply by 37. So our plan for solving to turn a 10 back into an X, first, we'll take the 10 and we'll divide by 37. Second, we'll find the log base 0.88 of the result. And third, we'll multiply by 4. This is going to require a calculating machine, like always. So we'll take the 10 and divide by 37 first. Now this is going to take place on a calculator, so I'm just going to write down stuff in between that I'm not actually going to be writing down. 10 divided by 37 is 0.270. Then I'll take the log base 0.88 of 0.27. And to do that, I'll take the log of 0.27, so log of the answer. Log of the answer divided by the log of 0.88. That's going to be 10.23. And then I'll take the 10.235 and multiply by 4. And we get 40.939, we'll call it. And so that still leads us to X equals 40.9 rounded to the nearest 10. We do have to remember the change of base formula for log of 0.88. Log base 0.88 of 0.270 is the calculator log of 0.27 divided by the calculator log of 0.88. So we do have to remember our change of base formula, but we can also solve that way. The best thing to do is whichever one you happen to remember to do. If you happen to remember both, whichever one is going to be faster. Yesterday, we had a lot of evidence as to where to start our search for the solution. Today, we didn't, so maybe today it would be faster if we remembered how to use the logarithms, doing inverse operations in reverse order. However, if we don't remember how to do inverse operations in reverse order and to use logarithms, then guess and check is what we have. Sometimes brute force is what we have to use. This particular problem gives us an opportunity to ask an interesting question. So let's find the half-life of p of x. Any exponential function that is decreasing will have a half-life. What this means is find the interval for a multiplier of 0.5. So that is find an interval for a multiplier of 0.5. So we just want to solve an equation again. So we'll take 37 times 0.88 to the x over 4 and try to figure out how long it takes this to get to half of 37. So 37 divided by 2 is 18.5. So how long will it take this function to go from 37 to 18.5? Now we can do the same thing that we did in the previous problem, only instead of starting with 10, we could start with 18.5. So if I take 18.5 and divide by 2, divide by 37. So if I take 18.5 and divide by 37, we unsurprisingly get 0.5. That's where the half-life came from in the first place. Then if we do the log base 0.88 of 0.5, using the change of base formula, I'll do the log of 0.5 divided by the log of 0.88. And then finally take the 5.422 and multiply by 4. So p of x is multiplied by 0.5 every 21.7 units. P of 0 is 37. And p of x is multiplied by 0.5 every 21.7 units. All right, that's the problem that I wanted to look at today. The important things to remember about this are that we always have guess and check in our pockets. If we know how to plug stuff into the function, we can always use that to solve the equation if we don't remember how to do logarithm business. But we should know both. Also, notice that decreasing by 12% every 4 units, we can't just divide the 12 by 4. It doesn't work out to exactly 3. It works out to 3.1. It's a little bit more than decreasing by 3% every 4 units. Because once we decrease by 3.1%, there's less around. So to get a whole 12% after 4 units, we have to decrease by a little bit more than 3% every 1 unit to make up for the amount that's decreasing. Those are the big takeaways for today. So that's going to do it for today. Use this information to go work on the final series quizzes that are up on the Canvas in their own module. And keep an eye out for some new final series quizzes. There are going to be 10. That's it for today. I'll see you all on tomorrow. Everybody have a good day, and thanks for playing.